PreCalc. We are in review, and this video starts with number 9. So what I will do for extra credit, we will look at number 9. You will pause the video in class and you will attempt the problem for a few minutes, and when enough time has elapsed, turn the video on, and if you get the answer correct, you get a tally, and it's not a true bingo, but it'll work similarly. So you put a tally mark at the top of your paper if you got it correct. And then we will go on to the next one, and so forth. Alright, so we're viewing exponentials and logarithmic functions, and we are going to look at the first one. Alright, I don't know how well this is showing up. I'm trying to videotape in a bright room, so I'll switch to a pen. Can't make erasures, so I'll see if it shows up any better. The first one is graphing an exponential, and the base is e. We have in the exponent x plus 2 and a minus 1 following the entire function. So you'll recall that this means something. So go ahead and graph it. Turn this off. Turn it on when you've got it graphed, and I want you to look for the domain, the x-intercept, and the asymptotes. Alright, here we are with the answer. Recall when the plus 2 hugs the x inside the argument, right next to the variable, it's a left right, and this one happens to be a left 2. And when the change or translation is outside of the function, it will be an up-down. So we recall e to the x. I'll graph that first. So e to the x, we will graph 2 points, x and y, when x is 0 and when x is 1. When x is 0, we have, I'm just graphing y, the basic graph, y equals e to the x first. So when I graph that, when x is 0, e to the 0 is 1. When x is 1, e to the 1 is e, which is about 2.7. So I'm going to graph this point, 0, 1. That point will be on most of our exponentials before we move them around, and 1, e. So about right there. That should be enough to remind you that exponentials tail off on one side and go zinging up on the other side. So that is the first step, but this tells me I have to move that to the left too. So take this point and I'll move it over 2. So I'll put an X there. And this point, I'll move that over 2. So I'm finding the second one, I'll dot in here. Alright, so now I've moved that whole function to the left too, as commanded by this, and now I have to drop it down 1. So this point will now be here. So I'll make and this point drops down 1. So there. So I'll make a very thick graph for the final one right there. So alright, so hopefully you get the gist of that one. And the domain is all the values for x, so you think of marching across with all the possible x values. At each one go up and down. Will it touch this graph? This graph will go forever in this direction, and even though it is widening slowly, it will go forever in this direction. So we say all x values are in the domain, and we say that by saying x is an element of the reals that communicates all real x's, or all real numbers. And the x-intercept is where it crosses the x-axis. So you can see here it's at -2, 0. And if you're not convinced of that, you can take the original and set this equal to 0, and solve that. And you'll see it does come out to x equals -2. And is there an asymptote? And it turns out the original one was this one, and it had an asymptote right at the x-axis, which is called y equals 0. That didn't change when we moved it over to the left 2, but when we went down 1, its asymptote moved down 1 as well. So we have an asymptote at y equals -1. So that graph, it will go forever in this direction, but it will always get closer to this fence, but never touching it. It's an electric fence. All right, so tally. Let's see, a tally if you got the graph, a tally if you got the domain, a tally if you got the x-intercept, and a tally if you got the asymptote. So up at the top you could have 4 tallies, and I hope you do. But if not, the important part is you can do it on the test. Not right now, although it's nice. On this section, you were asked to do these without a calculator. So this is saying, so go ahead and do all 4, turn off the video, and after a given number of minutes, turn it back on and check against my work. Right, here we are, 3. What exponent do I give 3 to get 729? So I'm just going to do 3 times 3 times 3. I might have to do some scratch work since I'm not using the calculator. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, come on old brain, 243. So I did 3 times 3 is 9, 27, and 81 and 243, so I'm not there yet. It's probably the next one, times 3. So let me check that. It is. So doing some scratch work there on the side, I found out that I had to use a 3 1, 2, 3, 4, 5, 6 times, and that gave me the answer 6. So what exponent do I give 3 to get 729? The answer is 6. All right, on this one, 4 raised to the log the base 4 of 32. Up in the exponent, I see I have the number that I raised 4 to get 32. So if I raise 4 to that number, I get 32. All right, so 32 is the answer to that. All right. I'm sorry, I've got to take something out of the oven, so I'll be back on part 2.